Hello, my young scientists, and welcome to Mr. Patrick's Laboratory. We are going to have a great episode again. Last week we had a great time with buoyancy, the upward force when we get things in water, the downward force of density, and how things are held up. We talked about how things sink and float, and we did all kinds of stuff. And one of the very last things that we did was this one, and it got me really thinking. Remember, we had pure water, we had an egg in the water, and it sinks. Water has a buoyant force on it, but it's not enough to keep it, the density goes down. Then we made salt water. We put a lot of salt, about 4 tablespoons of salt in there, and check this out. Raw egg inside there. Notice it floats very easily. Even if I touch it, it floats easily. Now, when I was going along, I did a few experiments right after the video, and I thought, you know what, I need to show my friends. And then it gave me a brilliant idea on what we're going to do for this week. So, as Miss Christie gets close, we're going to change this a little bit. Remember, this one is just regular water, and an egg sinks all the way to the bottom. This one was salt water. It is full of salt water. As a matter of fact, there's a little salt sitting in the bottom, so I mixed in as much as I could. Now I'm going to change this up a little bit. I'm going to make a bouncy egg. Let me show you what I mean. Take that out for a second. I'm going to pour out about half of this, but I'm going to pour it in the sink so I don't get in trouble here in Miss Christie's kitchen. Mr. Patrick's Laboratory. I'll be right back. So I'm going to pour out about half of it. And then what I'm going to do is I'm going to change it. Instead of it being all salt water, I'm going to take this egg out. Stay right there, my friend. And I'm going to put just regular water in there. It's not as salty. I spread it out a little bit. Okay? So I'm going to mix that in, make sure I got the water in there. Now, is it still salty? Yeah, it's still salty. But this time, when I put the egg in there, let's see if it does what I was playing with the other day. Oh, yeah. Now, watch how it's starting to bob up and down. I'm going to give it a little bit more water. Okay? Mix that in really good without breaking that raw egg. And I want you to notice what's happening. That egg is bobbing. Watch this thing. Really slow comes to the top. It's trying to sink. It's somewhere between sinking and floating. Okay? I'm going to give it just a little bit more water. And I'm going to try to get somewhere to the point where buoyancy. Oh, I did it, Miss Christie. Oh, it's trying to fall. Okay, stay in there, stay in there. Got to mix it in good. Let's see what it does. What I'm trying to get it is I'm trying to get the water and salt right to the level where it's somewhere balancing between all the way sinking and all the way floating. It's somewhere there. Look at it trying. I'll bet you can do this better than me. And so it's got salt water and regular water in it. And so I'm playing with the buoyancy of it. And so that's what we were learning. And I thought, man, this is so much fun. Water does so many cool things. How about we do things and talk about the mystery of water? Now, most of us know, I don't need my goggles for today, so I'll put them off to the side. We know that we have to have water, and we're around water all the time, but what we don't really understand is how amazing it really is. Now, I'm going to show you an example here for a minute. A lot of what we're going to do this week is going to be based on water, how amazing it is. We're going to do some tricks with water. You can amaze your parents. It's going to be awesome. But first, I want to teach you a couple of things. I'm going to take water to compare it to something else that looks like water. This is alcohol, isopropyl alcohol. This is what you would get on you if you go to the doctor and you have to get a shot. Okay? So they put it on a cotton swab, rub it on you, and then they get a shot. Okay? I'm going to put a couple of drops of isopropyl alcohol right there. Now, it's a little hard to get off of that plate. Okay? But I'm going to try to get an angle, but it goes completely flat. Completely flat. Now I'm going to compare that. Miss Christie's going to get the right angle for me. I'm going to compare that to a drip of water. Now I want you to see what water did. Now, I'm going to get an angle up here like this. Okay? Water mounds up on itself. It makes a little hill right there in front of my finger. Okay, I'm going to turn it like that for a second. Okay, and then I'm going to put it back like that. That's caused by surface tension. So think about it like this. Water molecules are really pretty special. Now, we don't really think of it like that because we're around it all the time. But water molecules are attracted to one another. Now, for my older scientist friends, water is polar, which means it has charges. And if you have a plus charge and a minus charge, what do they attract to? Other pluses and minuses. And so plus charge, minus charge, they attract each other. Well, water molecules are going to hold together like they're holding hands and really holding tight to one another. They're polar and they're holding together. And so when I put that drip on there, they hold together. This isopropyl alcohol, I'm going to go ahead and put the lid on it. It doesn't do that. When you put a drip of it, it goes completely flat. The molecules aren't attracted to one another. for my older scientist friends, that's a nonpolar compound. They're not attracted, okay? It's like saying this spoon is attracted to the table. Well, it's not, okay? There's no charges involved in that, okay? So we understand magnets. So water is polar, and other things are nonpolar. Now, surface tension is really holding that in that. So what we're going to do is we're going to do some amazing experiments. Many of them are going to come from some of the science we've already done together. But in the next couple of videos, this video and the next couple of videos, we're going to do some amazing things that only water does. So let's have some fun together. First thing we're going to do, I'm going to move these guys out of the way, is I'm going to take 2 cups, and I have water, and I put green food coloring so you can see it on the video. Now I also have a string, piece of string, and I picked actually a pretty long string. And so here's what I'm going to do. I'm going to get this correct in my hand, set it up right, put this in there like that. I'll hold it. And then what I'm going to do is I'm going to take the other end of the string and I'm going to put it in this cup. Now, I got to be real careful when I do this, but let's see how this works. We're going to pour. You got to go real slow at first. Miss Christie's going to get over here at this other cup. See what's happening? I'm pouring water down that string. So as water's going down that string, I want you to check out what's happening in the other cup. It's going down the string. Do you see the green in there? Okay, I'm going to pour it a little faster now, Miss Christie. Here it goes. And so I'm pouring water down a string. And I got to be really careful. I got to make sure I don't watch the video. I got to pay attention to what I'm doing. Here I go. Watch. I'm going to take this. Oops, it drips out a little bit. I got to be careful. I'll raise this top cup. I'm really going to start pouring now. Here we go. It's going to drip out just a little bit because I'm trying to hurry a little bit. But check out, kids, check out the amount of water in that bottom cup. I'm pouring water from one cup into another. Now I'm going to raise this one even higher. Really make that water go down that string. Woo! I bet, kids, I bet you can do this. It's really not too hard. You just have to be very careful as you go. Now you may think, you're doing a trick. I'm really not. I'm using surface tension. I'm doing something really cool with it. Now, this would be a cool one that you could do for your mom or your dad, and they won't figure out what you're doing. You got to practice it once or twice first. You don't have to put food coloring in it. But you can see there's water being poured into the other cup. Check how much I poured in there. Now, let me show you how to do it. Okay? Now, there's not a trick to it, but before I ever started, I took my string and I got it wet. And here's why. Now, remember a while ago, I told you we're going to talk about water. So I wore my blue shirt that looks like water because it's so much fun. And so what I did was I got water into my string. So my string is wet. Now we said that these molecules hold each other, right? And so what's going to happen is, I'll just start again. I won't do the whole thing again. But I put one end in here, pick up the cup, and then I hold it on the other side of this cup. And I slowly pour. And what's happening is I start pouring that green liquid. Water sticks to itself. Woo, it's going even better now. I did really good this time. Here it goes, here it goes. Woo, get up there close, Miss Christie. You can see, look at the water going down the string. Do you see that? You can see that water going down the string. Pretty good. It's going really good. Come down about 1.5 inches down that string, Miss Christie. You can really see that water on there. Can you see that? Boy, I'm really filling that other cup pretty quick. I'm going to try to pour a little faster. Look at it go. Woo! And you can pour water from one cup to another, and it's not like pouring spilling on. Now, I spilled a little because I was trying to hurry, and I dropped my string, so I put a little here. But don't worry, I figured out how I was going to take care of that. I'm going to put that back there. It takes a little practice, but people will say, you're doing magic. No, I'm not. I'm using science to do something really cool. Why? Because science is really fun. And so I'm going to pick up a little bit of this green with this paper towel, okay? And so when we talk about surface tension, there's another trick or fun thing you can do, and here's what you need. Probably at your house you have some kind of dropper. Now it may not look like this. This is a dropper that I have at school that I use in my chemistry class, but I bet you have like a medicine dropper or some kind of dropper like that, and all you need is a quarter. Okay? And so what I'm going to do here is a little bit of a challenge. And so what I want to do is I want to see how many drops of water I can put on a quarter. Now as Miss Christie gets closer, you'll watch right as I'm dripping that water on there. Here we go. 1, 2. Quick question, did I completely fill it up? No, there's a lot more that can go in there. 3, 4, 5, 6. Now I'm going to stop for a second. Can you see the surface tension? See how that is on there like that? Okay. 8, 9, 10, 11, 12. And I'm going to stop because I don't want to tell you how many. But I'm going to tell you this. You can put a whole lot more than 12 on there. And I want you to be steady and see how many you can. So you got to practice with your dropper before you ever do it. You want to get one drop at a time. By the way, see how it comes out as little circle drops? You ever wonder why? I know the answer. Surface tension. Those molecules are holding to one another. If you were using something other than water, it would just sort of pour out like that. It wouldn't come out as drops. Because water is awesome. And so here's the really fun one, kids. You can take 2 quarters, put 1 quarter in front of you and 1 in front of your brother, your sister, your mom, your dad, your grandma, whatever, and say, I challenge you. How many can you put on that quarter before it spills off onto the table? And then they can say, well, why is it doing that? And you can say surface tension. Surface tension is holding that water on there. Pretty cool, pretty cool. Now, when you start dealing with surface tension, you start dealing with water, there's all kinds of different things you can do. Now, I saw this one the other day and I thought, man, I've got to show this one. I've got to show this one to my little science friends because I hadn't seen this before. So here's what I'm going to do is I'm going to take this green water that I had, and all I did was I took a straw. It's a bendy straw. You probably have one of those that has a little accordion part in the middle, and all I did was, this is the part where you put your mouth on it and you would drink a drink, and I pulled it out a little bit, and then what I did was I folded it over, and then I cut it so that it's about the same length, okay? This little green one looks a little better. I stretched that one out way too far, but I'm just making a U or a V out of it. A U is better, okay? And then here's what I'm going to do. I'm going to take and I'm going to put it inside this green liquid. Now, you don't have to have green liquid. I just had green liquid that I was using for the other experiment, okay? And so what I'm doing is I'm squeezing it to get the bubbles out of it. Okay, so what I want to do is I want this thing to be full of water. It's not exactly full yet. I can tell, I can see the water line. And so I'm going to put it back in there and make sure I get some water. Now, what I'm going to do is called transferring water, okay? And so notice I have a cup. Oh, this is perfect. I have a cup of green water and then an empty cup. But I want some of this green water in here, but I want to use science. Watch what happens. I just filled this all the way up. Then I'm going to do this. Check out what's happening in that other cup. It's like magic. I'm not even touching it. It's going into the other cup. How's it doing that? Okay, it's called siphoning. And so I'm siphoning from one to another. Quick question, do you think all of this one will go into there? You're right, no, it won't. What did it do? They evened out. Miss Christie, I'm gonna try it again. I'm gonna try it again because I just think that one's pretty cool. And so I have a green straw, so I'm gonna pick another one real quick so that maybe you can see it a little bit better. And I'm gonna try this one that's yellow. And so maybe we can see a little bit better, and we're gonna make this one work. And some of you may say, hey, I've done that before. I have an aquarium, and I have gotten all of the water from my aquarium out before. So I'm gonna see, okay, so if Miss Christie gets close, you can see all that green liquid inside of there, okay? So I get the cups really close to one another, and all I do is turn it over quickly, like that, and all of a sudden it starts siphoning. Check that out. Watch that water going up. Now, does the water have to be green? No, that's a good question. I just have it green so all my friends can see it. And I need to make sure my tubes stay inside, and it will keep going until I get equal levels. That's called equilibrium for my older science friends. It's an equilibrium. And it gets to some kind of balance. That's what equilibrium means. But how cool is that? Have you ever seen that before? I hadn't. That was so cool. And so I saw a guy doing this. He had a really big aquarium full of water, and he needed to move some of the water to clean it for his fish. And so he had not just tiny tubes like this. He had really big tubes, and he stuck it down in the aquarium, and he turned it over really quick, and it was going from his aquarium into a bucket. And so when it was going into the bucket, he could get the water out, could clean it, and then put it back in there. And I thought, how's that happening? Water is awesome. And he didn't have to pick that whole thing up and pour it. He moved it very easily. Surface tension, all the water molecules, when they start being pulled one direction, they're being pulled over to that other side very easily because of science. It's cool. Water is awesome. So far, now I have the great one coming, the last one. You won't believe this last one. But we talked about bouncy eggs. By the way, Miss Christie, come over and look at that. It stopped moving. Hey, look how I did, kids. It's floating in between the bottom and the top, I got it. I just had to leave it alone for a couple of minutes. It did exactly what I wanted it to do. I bet you could get it exactly in the middle, but it did great, okay? And then after that, we figured out with surface tension how many drops you're gonna do this at home. By the way, if you do a picture of this, take a picture of this, put it in down below. I wanna see how many drops did you get on that quarter, okay? Before you got it to flow off the top. And then we also did string. We poured water down a string very easily, and then we just siphoned. We moved water from one place to another. In this last one, the most amazing one is last. And here's what we're going to use. I'll pick up a bunch of just supplies that I have, and then I'm going to tell you exactly what I'm doing, and then I'm going to let you try it. You can try it at home. This one looks like a real magic trick. Actually, one time, I saw a magician do this one on stage for a bunch of people. All I need is a baggie. It can be a quart-sized baggie, it can be a gallon-sized baggie, but it needs to zipper at the top. And then the other thing that I have are a bunch of matte pencils. Oops, I have a rubber band on that. I just have matte pencils. I also have a box of pencils, the brand new pencils that are sharpened also, okay? And so I have those are like matte pencils. They're red pencils that I use in my class sometime. And then I actually have just some brand new pencils as well. Now, if you're gonna use these, you need to have ones that are already sharpened, and those aren't sharpened. So I wanted to make sure you see that. I want ones that are sharpened, okay? So all of these guys are sharpened, and I have them ready to go. So what are you gonna do, Mr. Patrick? That's a great question. We're gonna do the most amazing one of the day. Here's what we're gonna do. I'm gonna take my baggie, and I'm gonna go to the sink, and I'm gonna fill up my baggie with water. Now, it doesn't have to be all the way to the top, but pretty close to all the way to the top. Now, Miss Christie's already getting nervous because I have water, and I'm not gonna do it at the sink. I'm gonna do it over the table. Don't tell her, okay? But when I close it up, I'm gonna make sure I do it over the sink so I don't spill it right here. All right, so here's what I got. I got a baggie, and I've got water in it. Now I have a sharp pencil. This is the important part, okay? And so now we already talked about surface tension. Watch what happens. Take the pencil, push it through. Oh my gosh, it's leaking everywhere. No, it's not. Let's try another one. How about that? How about one like that? Now, I'm not grabbing it as she backs up. I'm not doing this. Ugh. You know why? That'll hurt me. And so what I'm doing is I'm taking, but you're like, oh, you only used red. I don't have to use just red. There's a green one. Ooh, and I went uphill. Check that out. I'll turn it for you, Miss Christie. Check that out. Here is another one. Okay, and another one. And it's going to look like magic as I go along. The bag's not leaking at all. And you may think, why? Okay, here's the cool picture. Okay, here it comes. I'm going to turn it. They're coming out the other side. Why? Surface tension. And what's happening is this. This pencil is slick on the outside. Now, all I have to do is push it through. Now, I don't want to do it up near the top, but I want to do it somewhere else. Push it through pretty quick, not super quick. And so I just take them and push them through. Now, what happens is water's pushing, and as it's pushing on the bag, it seals itself around the pencil. Now, I tried this one time and made a mistake, and what I tried to use was a skewer. Now, a skewer is long and has a sharp end. That's perfect, except it doesn't have any paint on the outside. So what happens when you drop a piece of wood into water? It absorbs a little of it. And when it absorbs a little of it, then it starts leaking off the end of the skewer, and that's not what I want. So I had to find the right thing. So I tried out a bunch of stuff. And here's my last one. Check it out. Now, I'm going to try the trick I saw a famous person do. Watch this. I'm going to just set it on the table like this. Oh, if it'll lean. Look at that. Is it leaking all over the table? No. Why? Science is awesome. Surface tension. Water. In the next video, we're going to talk about some other cool things that you can do with water. They're going to look like magic tricks, might even fool your mom and dad, because water is awesome. And we're going to do some awesome things here on Mr. Patrick's Laboratory. Be careful with the pencils. Don't let them hurt you.